Okay, here we have Eagle Tree system with different files I can show you now, and it's a way to show you how important it is to make a nice and smooth inlet for ducted fan motors. I will show you in 4 steps. First, it's a 6 cell and it's a 4-inch fan, and it's a motor called KB45, and it's 1000 RPMs per voltage. Anyway, we have here the different figures. We have just to make it nice to see, the wind speed behind the fan, and then we have the pack voltage over here. Now it reached, this is a recording, so I stopped the recording here. It's like a player, so this is why it's showing some figures. And then we have the amp draw, and we have the RPM down here. This value is a little bit hard to get to know exactly. It has to be calculated to get the correct figures. This is just the voltage now. It's converted from it's a modified scale for fishing, and then it's cables from that to an analog to digital converter, and then it shows this value. So I have to calculate to get the correct value, and it's a little bit pity that it's not shown in the screen, but it's at least for me it's a little bit too expensive to let Eagle Tree to arrange so it can get it converted inside the system. So it's going to be like this for the moment. I will tell you that in this first file we're going to show it's 0 kilos when it's 1.28 there, and it's going to come up to 1.48, and that is equal with 1.56 kilos. I will start here to play this file. You can follow the amp draw. It's I usually wait a little bit. Now it starts rotating a little bit, and then I stabilize for full power for a short while. So here you can see just the value, but it's equal to 1.56 kilos, and you have the RPM and voltage and the ampere, and then it's winding down. Now I swapped to the next file, and this is maybe I forgot to mention before that the first run was without air inlet for the ducted fan, and now it's a homemade smooth air inlet, and I can show you quickly. It looks like this, if I can find it in the picture. Just easy made by yourself. Oh, now we'll see what's gonna happen when you put on this one. You can see the increase in power you get without an extra consumption. You can follow this value still. It's 0 kilo when it's 1.29 like that, and now we will end up in 1.58 when it's soon up to 1.58 here, and yeah, there we go, 1.59 even, and that is equal to 2.54 kilo thrust, and of course it's static thrust, so it's not a good value to measure when you have high speeds like this, but it's anyway a value you can know that you at least have that amount of thrust, and it's probably going to be better when you come up in there and fly a little bit faster. Okay, then you have seen that without inlet you get 1.56 kilos thrust, and with the inlet you get 2.54 kilos thrust, and that's with 6 cells lithium polymer. Now I will change to 8 cells to see what this motor can handle. Okay, now I have swapped to next file, and that is it's 8 cells now. And what you get up when you select that file, it gives you the maximum values. This is maximum ampere draw, and that means that the pack voltage goes down from originally it is around 33 volts, and this is maximum RPM 24,875 RPM. Some other values is maximum in different ways. This is not showing anything because it's the analog to digital conversion there. So I'm starting this now quickly to see. You have the 33 volts instead. You see that it when it winds up, it goes down in voltage and up in ampere draw there, and you see the wind speed, and we have 1.54 around. That's equal to 2.12 kilos in this configuration. So that's a value we have to keep in mind. So here we go with the last step, 8 cells in series, and just stop there quickly and see we have a little bit less voltage here. It's due to quite high consumption on the last run. It drops from the total maximum we had before was top value, and this is when it has been used for a short while, then it drops down just a little bit. And so here you can see 1.31 is just in the beginning here. I start this, it comes up and down sometimes, but this is 0 when it's 1.29 there at least. And then when it increases up now in RPM, we can see the values going up 1.7. It flickers sometimes to different values, but yeah, that's quite high. When I made my calculations anyway, it's 3.3 kilos thrust at with these values here. So I can show you if you just jump over to see 1.7 is somewhere around there, more or less. So that's the important thing, that it's gaining quite, it's more than 1 kilo when you're using in static thrust, when you're using inlet, compared to if you are not using anything at all. That was the thing I wanted to display for this time.